Hello everyone, today we're going to look at applications of the integral. So for our first example, it's going to be find a function whose derivative is 4x cubed minus 8 and that passes through the point 2, 5. So if I know the derivative, then we can integrate it to find the family of functions, so the functions plus a constant, and then we can use the point we were given to find that constant and therefore the particular function. So we start off with y equals the integral of the derivative we were given, so 4x cubed minus 8 dx. Then we integrate, and hopefully everyone gets x to the 4th minus 8x plus c. So there's the family of functions. That satisfies the first part. Now I need to find the c that satisfies the second part, that goes through the point 2, 5. So I plug in 5 for y, and I plug in 2 for 8, and I solve. And hopefully we can see that we're going to get 5, because 2 to the 4th is 16, 8 times 2 is also 16, those cancel, and c is 5. So our answer, make sure you actually answer the question, don't just end with c equals 5. Our answer is y equals x to the 4th minus 8x plus 5. Let's try another one. Find a function whose slope of the tangent line is 4 over x cubed plus 5x and that passes through -2, -3. So again, the slope of the tangent line is the derivative. Remember, we've got like 8 different definitions of the derivative, one of which is the slope of the tangent line. So again, to find y, we want to integrate that derivative. Notice that I also changed 4 over x cubed to 4 times x to the -3 so that I can use the power rule. Okay, so I integrate and I get -2x to the -2 plus 5/2 x squared plus c. And again, to find c, we're going to use the point that our function goes through. So we end up with -3 equals -2 over -2 squared. So again, I'm going back to what does to the power of -2 mean? It means 1 over that thing squared plus 5/2 times -2 squared. Don't forget, if you're going to plug this into your calculator, you need parentheses when you're squaring -2. Remember that -2 squared is 4, but if you plug this into your calculator, that is -4, so you have to be really careful. The calculator will do order of operations, not what you think it's trying to do. Okay, so you gotta be really careful when you're squaring negatives. But if we do it out, we should be getting c equals -25 over 2 or -12.5, whichever one you prefer, they're the same thing. And then again, our answer is plug that in for c. So y equals -2 over x squared plus 5 over 2 times x squared minus 25 over 2. Now we're actually going to do an application. We're going to apply it to something. So recall from before that the derivative of position is velocity, and the derivative of velocity is acceleration. Right? Velocity is the rate of change of position. Acceleration is the rate of change of velocity. So what we're going to do is we're going to reverse these guys and use the integration. So the integral of velocity is position, and the integral of acceleration is velocity. So I'm just solving these equations for the other part. So this is what we're going to use in our problems. There are 3 basic types of questions that can be asked in this case. The first one is, what is the equation for velocity or position? So the answer is an equation, and it involves an indefinite integral. So our answer would be something like v of t equals 3t minus 4. Another type is, what is the change in velocity or position? So the change in position, say, is a number, 25 feet, 32 feet per second. Okay, it's a number, and it involves a definite integral. So remember, the definite integral is the change in the function. The third type is, what is the velocity or the position at a certain time? So in this case, it's kind of a combination of the first two. The answer is a number, but it involves an indefinite integral. Okay, so these 3 times. What's the equation? What's the change in? What is? So you have to make sure that you know which type it is so that your answer matches it. So for the first one, if the acceleration of an object is a of t equals 16t miles per hour squared, find the velocity given that v of 2 equals 50 miles per hour. So it doesn't say find the velocity at a certain time. So just find the velocity means we want the equation for velocity. So this is the first type. What's the equation of the velocity function? So again, it's going to involve an indefinite integral, and we're going to use the fact that velocity is the integral of acceleration. Okay, so we're going to integrate this guy. So when we integrate 16t dt, we get 8t squared plus c. And again, we're going to use, I'm going to use this information to find c. So one of the biggest mistakes I see people do is they'll reverse their v and their t. So remember, what's inside the parentheses here is t, and what it's equal to is the function, which is v. And if you're ever having a problem, don't forget that you're going to have units here. Miles per hour is velocity, not time. So the 50 must be the velocity. So velocity is 50, t is 2, I solve, and I should be getting 18. And then again, the answer is the equation 8t squared plus 18. Okay. Let's try another one. The velocity of a plane is v of t equaling 30 times 12 minus t miles per hour, where t is in hours. Find how far does the plane travel in a 2-hour trip? Okay, so how far, that is a change in position. How far, or again, what's the change in position of the plane? So this is the second type of equation. I want to know the change in position, and that's going to involve a definite integral. So the definite integral is going to have the bounds of a 2-hour trip, which is starting at 0 and ending at 2. So I have the integral from 0 to 2 of 30 times 12 minus t dt. Notice I wasn't given a point, so I can't find c, which is another hint that it's a definite integral, because a definite integral doesn't include the constant. So I integrate. Remember, 30 is just a coefficient, so I'm ignoring it. I integrate 12, I integrate t, and then I plug the 30 back in. Plug in 2, I get 660. Plug in 0, I get 0. So my answer is 660 miles. That's how far the plane traveled. Here's another one. The acceleration in meters per second squared of an object was 2t squared. Find the height of the object after 6 seconds if the initial position is 2 meters and the initial velocity is 20 meters per second. So find the height, which is position, after a certain time. So this is that third type. It's going to involve an indefinite integral, but my answer is going to be a number, the height. So this involves acceleration, height, and velocity. So this involves all 3. So I'm going to have to actually do 2 integrals here. The first, I'm going to integrate the acceleration to find the velocity. Then I'm going to integrate the velocity to find position, or in this case, height. So I start with velocity is the integral of acceleration, which was 2t squared dt. I'm going to have 2/3 t cubed plus c. And then I have my initial velocity is 20 meters per second. So initial means start, and start means t is 0. So every time you see initial, that means t is 0. So 20, the velocity, equals 2/3 times 0 cubed plus c. So c is 20. So my velocity function is 2/3 t cubed plus 20. And I'm going to integrate my velocity to find position. So once I found velocity, I integrate again, and I get 1/6 t to the fourth plus 20t plus c. So it's not the same c, right? It's a different constant, but it's still just a constant, so we're still going to call it c. So now I have, again, the family of position functions. I'm going to use the fact that the initial position is 2. So again, s is 2, t is 0 because it's initial. I take this guy, I solve it for c, and I have that c is 2. So here is my position equation, and then it says find the height of the object after 6 seconds. So now I'm going to find s of 6. So every t becomes a 6. Plug it in, and hopefully you're getting 338 meters. Okay, so again, I used indefinite integrals, but my answer is a number at the end. Okay, so now we've done one of each of the types, and let's try another one. A ball is thrown vertically from the top of a building 300 feet high and hits the ground 10 seconds later. What was the initial velocity if the acceleration due to gravity is negative 32 feet per second squared? So I have acceleration and I have velocity. I also have a position, 300 feet, that's a position. So I am going to need all three equations, which means that I'm going to have to integrate twice again. Even though I'm asking for velocity, I am going to have to use position because that's what I'm given. But I'm going to start with velocity is the integral of acceleration. So I have negative 32t plus c. Now, I don't have anything about velocity. I don't have a point that includes velocity. Again, 300 feet, that's position. It hits the ground 10 seconds later. Ground is a position. Seconds is a time. So there's nothing about velocity. So what I'm going to do is I'm just going to go straight to position from here. So position is the integral of negative 32t plus c dt. So remember, c is some constant. Okay, so when I integrate it, I get ct. So whatever that c is times t. And then I have another constant from the integration. I'm not going to call it c because it's not the same c, and I don't want to have two c's in the same equation where they're not the same. So I'm just using the next letter over, which is d. Okay, so the d is from the constant of integration from position. So now what I have to do is figure out what these two pieces of information are telling me. So again, I know they have to do with position. So the ball is thrown vertically from the top of a building 300 feet high. The ball is thrown initially. So that is telling me that at t equals 0, the moment that I throw the ball, the position is 300. Okay, so t equals 0, s equals 300. That's one thing that I know. And then the other part that has a number says it hits the ground 10 seconds later. So 10 seconds is a time. So t is 10. What do I know? I know the ball hit the ground. What do I know about the ground? Its position is 0. Okay, so the ball is thrown vertically from the top of a building 300 feet high. Tells me that s is 300 when t is 0. Hits the ground 10 seconds later, tells me s is 0 when t equals 10. So I have these two pieces of information about the position. So what I want to do is use one of them to find one of my variables, c or d, and to use the other equation to find the other one. So what I want to do is I want to use this first equation first because it has a very lovely t equals 0. So I'm going to plug in 0 for t, s is 300, and this guy here is going to go away, so I'm only going to have d left. So 300 equals, that should be a negative 16, doesn't matter, I'm multiplying it by 0, plus t times 0, plus d, which gives me d is 300. Once I have d, I'll plug it in, and then I'll use my other equation to solve for c. So the other equation, s was 0 and t was 10. So 0 equals negative 16 times 10 squared plus 10 times c plus d, which we know is 300. And then I solve for c. And if we do it correctly, we should be getting 130 feet per second. So now I have to go back to what is the question asking. So what was the initial velocity? Again, initial means t is 0. So if t is 0, then my velocity is just c, my initial velocity. So this is my answer. And whenever your functions here, velocity, acceleration, position, whenever they are polynomials, their constant is always your initial. So in these cases, the c is my initial velocity. The d is my initial height. And that's always the case, again, assuming you have a polynomial. So c is my initial velocity, 130 feet per second. So we're going to look at another type of application, which is in electrical circuits. So we'll look at voltage across a capacitor. So the current, which we call I, in an electric circuit is equal to the time rate of change of the charge Q that passes a given point in a circuit. So hopefully we're noting words like rate of change, that means derivative. It also says the voltage V across a capacitor of capacitance C is given by V equals Q over C. So we're going to translate this into math. Again, the rate of change, the time rate of change, means d dt. So I is dq dt, the time rate of change of the charge. So if we integrate that, we're going to get that q is the integral of I of t dt. And then v is q over c, but q is the integral, so v is 1 over c, the integral of I of t dt. And then just so that we're all clear on the units, current is in amperes, charge is in coulombs, time is in seconds, and the capacitance is in farads. I think that's how you say it, I could be wrong. So the current is given by I of t equals 4t cubed plus 1. Find an expression for the charge that passes a point in the circuit if q equals 2 when t equals 0. So again, q of t is the integral of I of t dt. So I'm going to plug in my I of t. And then we integrate. So it's just the power rule. So 4t cubed becomes t to the fourth. 1 dt becomes t plus our constant of integration. We're going to use this second piece of information to find c. So if q equals 2 when t of 0, that means q of 0 is 2. And we're going to plug that in. So 2 equals 0 to the fourth plus 0 plus c. So c is 2. And that gives us our final answer as t to the fourth plus t plus 2. So a lot of times I'll have people who end with their answer of c equals 2. But remember the question, it says find an expression for the charge. So my answer is actually the entire equation q of t equals with that c plugged in. So let's try another one. The voltage across a 2F capacitor is 2.5 volts. Find the voltage after 5 seconds if a current given by I of t equals the cubed root of 1 plus 3t further charges the capacitor. So we're going to use the equation that V equals 1 over c times the integral of I of t dt. And that was one of our givens. We'll plug in I of t. While I'm plugging it in, I'm also going to convert this cubed root to the power of 1/3 because I know I'm going to need a power in order to do the power rule. And so remember, the nth root is to the power of 1 over n. So the cubed root is to the 1 over 3 power. My c is 2, so that's where this 1/2 is coming from. Yep. And in order to integrate this, we do have a function being raised to a power, so we need u substitution. So u is that function being raised to a power, so 1 plus 3t, which makes du 3 dt. And then I don't have a 3 in my integral, so I'm going to divide both sides by 3 and get 1/3 du equals dt. So that this will go in for dt, and then 1 plus 3t will be my u. So I've got my 1/2, my integral, again my 1/3, then it's u to the 1/3 du. So my 1/2 and my 1/3 is this 1/6 here. Add 1 to my power of a third and I get 4/3. Divide by 4/3 is multiplying by 3/4. So I'm getting this 1/6 times 3/4. Make sure you simplify that. Right, you can cancel a 3 on the top and bottom. So when I plug in my u, I'm also simplifying again. So I'll get 1/8 times my u, 1 plus 3t to the 4/3, plus my constant. And then I'm going to use the fact that the voltage across the capacitor is 2.5 volts. So that means that my V of, say, 0, or my V naught, my initial voltage, is 2.5. So here it is, my 2.5, I'm plugging in t is 0. Simplify the right-hand side, I get 2.5 equals 1/8 plus c. So c equals 2.5 minus 1/8, so 2.375. We're looking for the voltage after 5 seconds, so I'm going to plug that 5 in right away. And again, I am changing, or rather I'm changing my plus c, this plus c, I'll get there eventually, this plus c into my 2.375 and plugging in 5. Shove that into your calculator, it's not going to be something pretty, but rounded we get 7.41 volts after 5 seconds. Let's try another one. The current in a circuit is given by I of t equals 6t squared plus 3. Find an expression for the charge that passes a point in the circuit if q equals 3 when t equals 0, and determine the total charge that passes the point in 4.0 seconds. So we have two things to do here. We have to find the expression for q, and then find the total charge in 4 seconds. So this is the two-parter. So again, we'll start with the fact that q of t is the integral of I of t dt. Plug in our I, so 6t squared plus 3. Again, integrating is just the power rule, so 6t squared becomes 2t cubed, 3 becomes 3t, plus our constant. And again, we're going to use this fact to find our constant. There we go. So 3 equals 2 times 0 cubed plus 3 times 0 plus c. So c is 3. So the first part of the question, the expression for the charge, is q of t equals 2t cubed plus 3t plus 3. Again, we just have to make sure that we're plugging in our c. And the second part, determine the total charge that passes the point in 4.0 seconds. So that's just q of 4. So we'll plug in 4 for all of my t's, and we get 143. Charge is coulombs, so 143 coulombs. For our last example, the voltage across the capacitor of 5F is 10 volts. Find the voltage after 15 seconds if the current is given by I of t equals 2 plus t cubed over 100. So again, we're looking for the voltage, so that's 1 over c times the integral of I of t dt. C, the capacitance is 5, so 1 over 5. And then my formula here for I of t. I again have a function being raised to a power, so I'm going to use u substitution. So u is going to be that 2 plus t. du is a very lovely dt, so my substitution is not going to be too bad. So I have my 1/5 and my 1/100th, that's going to give me 1 over 500. And then my u is my 2 plus t, so u cubed. dt is du, so there's no other coefficient I have to worry about. Integrating this is just the power rule. I'm going to clean it up. 1 over 500 times 1 over 4 is 1 over 2,000. So we'll clean that up, we'll plug in what u is. And then we will use, again, this initial voltage here to find c. So 10 equals 1 over 2,000 times 2 plus 0 to the 4th plus c. So 10 equals 0.008 plus C, and C equals 9.992. I am looking for the voltage after 15 seconds, so I'm going to plug that in, and don't forget to actually use your equation plus your C. So this is my equation I'm going to be using here. I'm going to plug in 15. Again, use your calculator. It's going to be, this number here is going to be very big. And whoops, that 120 lost a couple zeros there. That should be 1 over 2,000, not 1 over 20. And we should be getting 51.7525 volts. Okay, so make sure that you read through the book and try out the homework, and let me know if you have any questions. Thanks.